Hello to everyone. So for today's lesson, we are going to discuss about tangent. So let us define first what is tangent. So when we say tangent is a line that intersects the circle at exactly one point. So the point of intersection is what we call as the point of tangency. So here, the point of intersection is point P. So in our illustration or figure, so we have circle C, and then we have line PA or AP intersect at exactly one point here. So this is what we call as the point of tangency. Then this tangent line is perpendicular to the segment CP, which is the radius of the circle. Let us answer example number 1. Line AP is tangent to circle C at P, at point P. If CP, segment CP, equals 14 centimeters and segment AP equals 68 centimeters, how far is point A from center C? So meaning from center C is here. So point A from center C. So this is the so we have a right triangle here. If we will label the figure, so this is CP, so which is equals to 14 cm, and then this is AP, 68 cm. We are going to find segment CA. I know you have already knowledge about Pythagorean Theorem. We can apply it here, especially this is a right triangle. So the missing is the hypotenuse. Using the formula of Pythagorean, we have a squared plus b squared is equals to c squared, or c squared is equals to a squared plus b squared. So in this case, c squared represent the segment AC or CA. Now, substituting, if we will use this formula, so we have now CA squared is equals to CP squared plus AP squared. Then we have now CA, or we can write this as AC. Okay, so AC squared. So AC squared is equals to 14 squared plus 68 squared. Then AC squared equals 14 times 14. You can use your calculator. So it's equals to 196. Then plus 68 squared is equals to 4,624. Then add the 2 is equals to 4,820. So we have AC squared here. So how will you remove the exponent 2? We are going to apply the square root property, both sides of the equation. Cancel this in the index. What is left is AC equals square root of 4,820 So the answer is 69.42. 69.43 rounded up to the nearest hundreds. So centimeters. So this is now the answer. So let us discuss about this theorem. We call this as the tangent segments theorem. So we have again circle C. The two tangents here are segment AD congruent. So this is the symbol for congruent. Congruent to segment BD. Then also the angles here, this is a right angle, then this is a right angle. So they are also congruent, so they are equal. Then of course the radius are equal. Then the angle here, this angle is also equals to this angle. So that is all about the tangent segment theorem. Okay, so let's proceed now to example number 2 about tangent. In the figure, quadrilateral ACAG is a circumscribed quadrilateral. Points B, D, F, and H are the points of tangency. If segment AB equals 4 cm, segment CD equals 3 cm, segment DE equals 5 cm, and segment GF equals 4 cm, find the following. Letter A, segment AH. Letter B, segment AC. Letter C, segment GE. And letter D, the perimeter of quadrilateral ACAG. Now, let us plot the given. So let's start with segment AB, which is equals to 4 cm. Another is segment CD, 3 cm. Segment DE, 5 cm. And segment GF, 4 cm. So I know you have already an idea or knowledge about the tangent segments theorem. If we are going to apply it here, we have tangent AB, it intersects at exactly one point here, then tangent AH. So if the two tangents intersect at one point, so these segments are equal. So which means segment AH congruent to segment AB. So this is also equals to 4 cm. And if we have segment CD, so this is tangent, then another tangent here, so they are also equal. So we have 3 cm also here. And then segment DE is a tangent. Then segment EF, another tangent line. It intersects at exactly one point, so they are congruent. So this is also equals to 5 cm. And the last one we have tangent GF congruent to tangent GH. So this is also 4 cm. So from that, we can now answer what is the value of segment AH. So the answer here is 4 cm, 4 centimeters. Very easy. And then for segment AC, starting at this point until here, so just add 4 plus 3, 4 plus 3 is equals to 7 cm. And for GE, so just add 4 plus 5, so the answer is 9 cm. 4 plus 5 is equals to 9 cm. And then for letter D, find the perimeter of quadrilateral ACAG. So the formula or the solution will be is equals to, just add all the sides. So we have 4 plus 3, so AC, segment AC plus segment CE plus segment EG plus segment GA. Okay. And then substitution. 4 plus 3, we have 7 is equals to 7. And then 3 plus 5 is equals to 8. 5 plus 4 is equals to 9. Then 4 plus 4 is equals to 8. So adding all together, 7 plus 8, we have now 15. 15 plus 9 is equals to 24. 24 plus 8 is equals to 32 centimeters. So this is now the perimeter. So let us discuss example number 3 about tangent. A belt fits tightly around 2 gears as shown below. Find the distance between the centers of the gears. So we have the illustration. The radius of the first gear is 3 cm. Then the distance from point here, point of tangency, until here is 16 cm. Then another radius for the second gear is 5 cm. So we are asked to find the distance between the centers. So the center, first thing to do is we are going to assign variables or letters here. Let's say this is center A, point of tangency is B, we have C, then we have center D. So the question now, we will find the distance point A to B, point A to D here. So we will find the distance. This is now the question. Now, so the radius is 3. We will draw a broken line here or dashed line in order to form a rectangle. Okay, so from here you can draw a dashed line. Okay, so like that. Look at the figure now. This is 3. Of course, this is also 3 cm. Then the remaining is 2 cm. Correct? Because from here, from point B to C is 5 cm. 3 plus 2 equals 5. Then this is now a rectangle. Then this is also 90 degrees. So this will serve as the hypotenuse. So from that, we can use the Pythagorean Theorem in order to find segment AD, the distance between the centers. So we have AD squared is equals to, we will assign here, let's say this is point A. So AD squared plus AA squared. AA squared. So this is also equals to 16 cm because this is a rectangle. Okay, so we have now AD squared is equals to, which is the center's distance. AD is equals to 2 squared plus 16 squared. So it's equals to 4 plus, so 16 squared, let us find the answer, is equals to 256. Then add 4. The answer is 260. So we are going to apply square root property to find the value of AD. So cancel this. AD is equals to, or segment AD is equals to 260 square root is equals to 16.12. So approximately 16.12 cm is the distance. In your activity, you are going to answer these problems about tangent, starting from number 43, number 44, 45, 46, 47, and number 48. Write your complete solution in your notebook. Copy the question and the figure and write your complete solution. Okay, bye-bye. Thank you.